Hi guys, in this video we're going to be doing a implement rapid per VLAN spanning tree lab, and this is part of the Boson CCNA NetSim labs. So without further ado, we're just gonna get into it. If you look at the topology, we've got 6 switches here interconnected. We've got a host connected at the end of switch 1. Now the objective is explained. So to address the relatively slow transition time of spanning tree protocol enabled port to the forwarding state, the IEEE Institute of Electrical and Electronic Engineers developed the I221W standard, which defines rapid spanning tree. Later on, per VLAN spanning tree was implemented. So really that goes more into the history of the protocols. But you can see, however, per VLAN spanning tree is not capable of using 801.q encapsulation to tunnel traffic on a switch's switch. Spanning tree and per VLAN spanning tree, on the other hand, can both use 801.q encapsulation to tunnel traffic on a switch. Rapid per VLAN spanning tree implements separate rapid spanning tree instances per VLAN, but by default, Cisco switches use rapid per VLAN spanning tree. Rapid per VLAN plus. In this lab, you will examine and configure a switch network that implements rapid per VLAN spanning tree. So here we have the topology. There's some of the basic commands for spanning tree. So show spanning tree displays the parameters for all VLANs, contains the VLAN name, status, and ports assigned to it. Spanning dash tree port fast enables port fast on interface. Spanning dash tree VLAN ID priority value sets the spanning tree priority value must be a multiple of 4096. So it must be an increment of that. Spanning dash tree VLAN ID root primary. This configures the spanning tree priority value to ensure the switch becomes the root bridge. And similarly, spanning dash tree VLAN ID root secondary configures the spanning tree priority value to ensure the switch becomes the secondary root bridge. And if we get into it now, IP addresses used in this lab are shown in the tables below. So we've got switches 1 to 6, they're all in VLAN 1, and we've got they're all configured as below: 192.168.100.1 for switch 1, then .2 for switch 2, .3 for switch 3, .4 for switch 4, .5 for switch 5, and .6 for switch 6. And we've got a /24 bit subnet mask here. So if you were to convert this into binary, you would see that this would be 8 bits, 0 bits. So that makes a 24-bit subnet mask. You've got host 1 here. It's got .100 IP address, 24-bit subnet mask, default gateway of .254. Let's go into the lab now. So allow the time for the networks to converge. Then on switch 1, 2, 3, 4, 5, and 6, issue the commands necessary to display spanning tree information. Which switch is the root bridge? How do you know? So we load up switch 1 now. And here we can load up switch 2, 3, 4, 5, and 6 there, and we'll do host 1 as well. So you can see now they're all displaying on the top here. So we need to ensure the commands necessary to display spanning tree information. Which switch is the root bridge? How do you know? So if we go into switch 1 now, and we go into it. Need to type en, or which is enable, to go into privilege exec mode. Type show spanning dash tree. Yeah, if I press the tab, it completes it for me. That now gives me the output, which gives me information. So I can see priority 32769, which is the default priority you'd get, and the address 000C.1289.3959, and that's for the root ID. But if I look at the bridge ID, I can see that the MAC address is the same, and in fact it says here this bridge is the root, so I know this is the root bridge. Okay, but we can do the same thing on all the other switches as well. So let's get on to switch 2, type in for enable. That takes us to privilege exec mode. Now we can do show spanning dash tree. Now we can see here we've got a different bridge ID this time. The address is different. interfaces we can see though. So if we compare this one, the last one, you can see all these on forwarding status. Okay, all forwarding. None of these ports are blocking. None of these ports are blocking. This is the root bridge, so there would be no need to block any ports that in the root bridge. Roles are all designated. All designated. Here on however, we've got alternate port F0 FA 0/0. So we're here now. So FA is 0/0. It's alternate is an alternate mode. It's an alternate port role. Status blocking. It's got a cost of 38. 128.1 is the priority number, the point to point, and FA 0/1 is the root port. It's forwarding. It's got a cost of 19. Cost of 19, if I'm correct, is normally it's a fast Ethernet, if I remember correctly. Fast Ethernet is the cost of a fast Ethernet link. 128.2 is the priority number. P2P point to point is the type of interface. It is designated. So FA is 0/2 designated role. Forwarding status 38 cost. 128.3. So here we can see root designated alternate. So which interface must be the root one then? Well, I'd imagine it'd be this one. This one would be the FA 0/1, because it's only got one link to switch 1, which is the root. Whereas this one has only got one. This one is directly facing the port. This one is directly facing connected to the switch 1. This one is connected to switch 3, and then would have to go to traverse another link to get to switch 1, like this. And this one here would also have to go to switch 4 and then go to switch 1. So this one is directly connected, and that must be the root. Look at switch 3. Enable show spanning -tree. You can see now we've got a different bridge ID again, 000C 1380353A. Got 5 interfaces coming out of switch 3 in the topology, which is there. So as you can see, this one 1 2 3 4 5 it's got 5 ports, 5 links that are connected to it. Switch 4, enable show spanning -tree. Again, we've got 5 interfaces going out of it, designated blocking, forwarding, blocking. Switch 4 here goes 1 2 3 4 5. Switch 5, this will have 3 interfaces going out of it, and this one also has 3 interfaces going out of it. So we can see enable, sorry, mistype that in, oh sorry, try again, enable show spanning -tree. Got 3 interfaces going out of it, as you can see in the topology. So we've got 3 interfaces here, and also if you look in the topology, you can see 3 interfaces going out to switch 5 there. So 1 2 3, 1 2 3, and switch 6. Privileged exec mode, show spanning. Okay, just show SP. Click tab, and now it will complete the command for me. So again, 3 interfaces going out to that. Route designated and alternate. If you look at the cost, FA00, that's only 38. So which is for switch 6. Now you look at the topology. Switch 6, you've got 3 interfaces going out of it. But if you look at this one, so you look at this interface, this link, that is the shortest path you've got there. So that is the shortest path in terms of the. I know that a fast Ethernet link has a cost of 19. A gigabit link has a cost of 4. A fast, let's say 10 gig link has a cost of 2. So if this tells me, because it has a cost of 38, well, it's only going to have a cost of 38 if it's got 19 and 19. If the links connected to it are both fast Ethernet, which have a cost of 19. So that tells me the route has a 2, as is only connected to the route by 2 links. And if I look at this is the only path here which has 2 links taking it to the route bridge. So this tells me that this one is the route. So we've logged onto all the devices now. We've checked all the spanning tree tables there. So we know that which one's the route bridge. We know switch 1. Why it clearly tells us there. Even if that wasn't there, we'd know, because we can just look at the addresses and we can see, okay, these 2 match. Apologies. So this and this match. Now, that was the first exercise. In the next video, we will do the second exercise, which is based on the output you previously generated, how many VLANs are configured with rapid per VLAN spanning tree on the switch.